Welcome back to The Explainer. So today, we're diving straight into this really cool source chapter called Shadow Story, or Togaloo. It basically takes stuff that looks like, just simple childhood play and completely reveals the foundational geometry hiding right beneath the surface. And honestly, the Togaloo Gumbaya Sitarata is the perfect starting point for this. It's this absolutely beautiful shadow puppetry art form from Karnataka that brings these massive, sweeping scenes from Indian epics to life. In the chapter, Nakul and his friends are totally mesmerized watching this at a village fair. It's such a clever hook, right? Because before we even realize we're learning math, we're totally drawn in by the magic of shadows dancing in the light.
To map out our adventure today, here's the game plan. First, the magic of shadows. Second, investigating light and shape. Third, hide-and-seek shapes. Fourth, folding edges and corners. And finally, jumping number patterns. All right, let's kick things off with Section 1, the magic of shadows.
So the text does this really smart pivot from those elaborate puppets to something you can literally do right now. Seriously, with just your hands and a single light source, you can craft these distinct animal silhouettes, like flying birds, bounding rabbits, howling wolves, the whole shebang. It just goes to show that the physical principles of blocking light to create shapes, they're totally universal. You don't need to be a master puppeteer. You really just need to understand how shapes interact with light.
Which brings us right into Section 2, investigating light and shape.
Now, obviously, a shadow's size changes depending on where you hold the torch, right? But here's the really crucial takeaway. 3D objects cast flat, 2D shadows. Think about it when you shine a light on a three-dimensional cone, the flat shadow it casts is actually a two-dimensional triangle. A 3D sphere? That gives you a flat 2D circle. A cylinder drops a rectangle. It's this incredibly natural, real-world translation from 3D space straight into 2D geometry, happening right in front of us.
But wait, before we start categorizing all those flat shapes, let's think about how shadows behave in the real world as the day goes on. Like your longest shadows stretching out in the late afternoon versus your absolute shortest shadows right around noon. The text poses a really fascinating question here, and I want you to think about this. When does a shadow completely vanish? Is it only when the lights go out, or is there some other trick to it? Hold on to that thought. Moving right along to Section 3, hide and seek shapes.
To help us visualize all this, the chapter uses a really fun color code. So triangles are red, circles are green, rectangles are yellow, and squares are blue. It then basically turns into a game, challenging us to find where these shapes are hiding out in completely ordinary everyday objects. For example, it points out that our green circles absolutely love to hide in clock faces or bouncing balls, while yellow rectangles are super easy to spot in things like shoeboxes or wooden photo frames. Now, the text jokingly notes that our red triangle and blue square are kind of confused and wondering where they can hide in the real world. So I'll give you a second to play detective here. Just look around the room you're in right now. Where exactly could a triangle or a square be hiding? Maybe a square is lurking in a window pane or a floor tile. And a triangle? Maybe a folded napkin or the corner bracket of a shelf. It really just proves that geometry is literally everywhere once you start looking. All right, let's jump to Section 4, folding edges and corners. So as we start looking closer at all these objects, we really have to contrast their boundaries. Straight edges, like the sides of a book, well, they meet to form sharp corners. But curved edges, like the outline of a coin, they're smooth and continuous, no sharp points at all. Grasping this simple distinction between straight and curved is basically the ultimate key to classifying every single geometric shape we ever encounter. To get a real hands-on feel for how corners and edges work, the chapter outlines this super clever origami exercise. We start with a flat, square piece of paper. Step 2, we fold it in half to instantly make a triangle. Step 3, we fold 2 corners down to make little ears. And finally, Step 4, we fold the bottom corner up to make a nose. It's so cool because the key insight here isn't just making a cute paper dog. It's noticing how the number of edges and corners literally changes with every single fold. Think about it. A square starts with 4 corners, but the second you fold it diagonally, boom, it's a triangle with 3. Every new fold creates completely new straight edges and totally redistributes the corners. It's just a fantastic way to actually feel the math changing right in your hands. And that brings us to our final section, number 5, jumping number patterns.
Here, the text introduces us to Kiku the rabbit, who is happily jumping along a path of numbered tiles. Kiku starts on tile number 1, then he jumps to tile number 4, which is a jump of exactly 3 spaces. So if he keeps applying that exact same rule over and over, what number tile is he going to land on next?
Yep, you guessed it. He lands on 7. 4 plus a jump of 3 gets us right to 7.
And then another jump of 3 takes him straight to 10.
Keep that going, and he lands on 13. You get the idea. It perfectly shows how one simple rule creates this infinite, completely predictable pattern. Actually, this brilliantly ties the whole chapter together, because whether it's a predictable shadow cast by a flashlight, a predictable number of corners on folded paper, or a predictable sequence of numbers on a path, math is really just about finding the underlying rules. To wrap up this explainer, I want to leave you with one final mission. Take another look around your room right now and see if you can spot just one single object that combines both straight and curved edges. A computer mouse? Maybe a guitar? Math and geometry aren't just stuck in some textbook. They are literally the hidden architecture of the physical world all around us. So, what other hidden rules are you going to discover today? Thanks for tuning in, and I'll catch you in the next explainer.